All right, dude, we are live. What's up, guys? This is Dem Keys, and sorry, started out the stream and my voice was kind of weird. Yeah, what's up, guys? This is Dem Keys, and today we are going to be continuing um, Kaggle Learn. We're going to be continuing learning through Kaggle Learn, and we are starting off with actually not starting off. We are today we are starting with um, the intermediate machine learning course. Give me a second here. Let me show it to you guys. This course. So today we're going to be starting this course. I've already finished the tutorial section of the first chapter. It wasn't very long. There isn't too much to read there, so that's fine. Now we're going to be doing the exercise portion of chapter one, and I'm excited. I'm excited to um, go through all of these chapters because we're going to be learning a bunch of things that I probably don't know or hold on. Let's see what chapters there are. Yeah, yeah. Okay. So I probably know I probably know how to handle missing values to a certain extent. But then I think the further stuff like categorical variables, pipelines, cross validation, XGBoost, definitely. I don't know about this data leakage as well. There's gonna be lots to learn in this course, so I'm excited for that. Now, yesterday I did something that I'm proud of. So this give me a second here. Let me show you guys. So, okay, if you look at the background, in the background, um, you can see a matrix rain kind of thing happening. And this is happening because of a program called Rusty Rain. This is a program written in Rust that basically implements a matrix rain kind of effect in your terminal. And dude, the program is amazing. It's got a bunch of customization options, which is why I was able to get it to this state. Because in the default state, the rain is a little faster, and actually, I can show it to you guys. I can show you guys what the default state of the program looks like. It's not like all that different, but like the rain is a little faster, and what more? Yeah, it's a green colored thing, and I don't know what color the head of the rain is. Let me show it to you guys here. Let's just do Rusty Rain alone. So this is what it looks like by default, and because of the customization options that are available, let me see what it looks like here. Yeah, this is what it looks like by default, and because of the customization options, I'm able to make it look like this. Something that I wanted was to be able to set the background color for these rain particles, and they didn't have that option implemented in Rusty Rain. So I went through the code base. I also took help from Gemini CLI to understand the code base and what is going on and what different options are available, how the options are being parsed, and how they are being implemented. After taking some time to study that, I implemented a background color effect. Give me a second here. We need some sound because my voice is shaking. Okay, yeah, better. Great. So yeah, I implemented a background color feature in it. I wish I could show it right now. Actually, there might be a way that I can show it. Hold on. I can show it. Um, Hold on. Let's detach from this and get into this and here, Rusty Rain. Yeah. Uh, did I hit? Yeah. Okay. So this is hold on. What are you guys seeing? Yeah. Okay. Cool. So this I implemented the background color thing. Here you can see the background color is black. I can change the background color to something like, hold on. What is it? RGB. So let's say um I don't know, let's give 30 on this. Okay, let's make it a little bit higher. Let's say 50. Yeah, you can see like a dark blue kind of effect, a dark blue kind of background color going on. So yeah, I wanted to implement this feature. I implemented it, and I think for the first time ever, I submitted a pull request to another project, which is basically this project. So I got a chance to experience what that whole workflow is like, where you first fork that repo, and then you clone it so you have a local copy, then you create a branch, you work on the branch, you commit to the branch, and then you push that branch to your your fork of that repo. So then your fork has that branch, and then you submit a pull request to the upstream repo, which is the main repo, to merge your branch into main. Um, and that was an interesting experience. Give me a second here. Let me. Yeah. So that was an interesting experience, and I'm also super excited that, uh, despite being brand new to Rust, I still managed to add that kind of feature into somebody's program. I don't know. At least for me, that's something to be proud of. That tells me that, hey, I can be a little more confident in my capabilities of doing Rust. Dude, speaking of Rust, okay, we're supposed to be doing this ML stuff right now, but real quick, speaking of Rust, I was looking into, and I was surprised because, okay, I was I think a couple of weeks back I was looking into, or maybe it was 1 or 2 weeks back. I don't remember. Either way, I was looking. Wait, give me a second. Let me hydrate, and then I'll continue. Dude, I burned I burned camphor in my room. I think an hour before the stream. I burned it in my room too, because I noticed like one or two flying insects. So to just get rid of them, I basically just put camphor smoke in the entire room, and yeah, that's gonna take effect. But an unfortunate side effect of that is that it kind of affects me as well, and so I think that's affecting my ability to speak right now. Okay, anyways, so I don't remember. I think it was a week or two back, maybe 3 weeks back. I don't remember. I was looking into doing ML stuff with Rust. Actually, not ML stuff, deep learning stuff, not machine learning, deep learning stuff. And two two libraries that popped up were Torch Rust, which is Rust bindings. Well, Torch Rust is um, Rust bindings for for the Torch C++ library, and then we have Candle, which is a pure Rust library for deep learning stuff. It's it's got like its own design, its own philosophy and stuff, and it is great. Apparently, it's great for embedded devices as well because of its very minimalist approach, and more importantly, it's no STD support, which basically means that it doesn't use the standard library. Actually, where did I read that? Let me just confirm that so I'm not giving out wrong information, because I do remember Candle being mentioned to have no STD support. Give me a second here, because okay, the so the reason why no STD is important is because this makes it so you can run these programs on other devices that don't necessarily implement the standard library, because the standard library usually requires you to have some kind of OS that it's running on, and so it's going to give you extra features like access to threading, access to a file system, access to various OS features, right? But when you're running on an embedded device that doesn't necessarily have an OS, then trying to use STD isn't really going to work out. So you kind of want to have a no STD approach. That is why when you're learning Rust for embedded devices, or embedded Rust, basically, when you're learning embedded Rust, they do offer the STD and the no STD approach, and quite a lot of people go with the no STD approach. Now I'm trying to. Okay, so don't take my word. Um, don't take my word for the no STD thing with Candle, but yeah, for embedded Rust programming, I wanted to look for something that had no STD support. And I don't remember why I started talking about no STD. Either way, I was looking into libraries that I could use for deep learning with Rust, and I found Torch and I found Candle. But a couple months back, when I was looking into this, I remember finding another library called Burn, which I'd completely forgotten about. And like a week or two back, when I was doing this research again, Burn didn't pop up for whatever reason in my search. I don't remember how I was searching, but I it Burn just didn't pop up. But then yesterday, I happened to see Burn being mentioned, and then I looked it up and I was like, holy shit, I forgot this thing exists. I need to look I need to look into this library as well, especially now that I'm getting more and more comfortable with Rust. I need to look into this library as well. And it's kind of interesting because they have the concept of backends where you can write essentially agnostic code, generic code that doesn't really care about what the backend is, and then you can choose a specific backend that's going to be executing this code. And some of the backends that are available are Torch and Candle, and also ND which Burn's implementation of ND does have no STD support, and because of that, I have some hope that I would be able to run these models, if not the training, at least the inference. I would like to start with the inference at least. If not the training, then at least the inference can be done on embedded devices. And I want to try that out because I have a bunch of ESP32s lying around. ESP32 hardware is super cheap as well, so I can buy more microcontrollers if I need, and I can get started with doing embedded deep learning stuff. Because, like, there's going to be a point where I kind of bridge my knowledge of machine learning, deep learning, robotics, and electronics together. And I feel like once I do that, there's going to be a lot of very interesting stuff that I'm going to be able to do. Okay. Anyways, I'm excited for Burn. I think I'm going to be learning how to use Burn. I do need to continue my Rust studies because there's still, some of the more advanced concepts that I need to learn. I kind of was taking a break from that uh, because I wanted to focus on doing Kaggle learn stuff, which is what we are doing now as well. But yeah, I need to finish that and then get started with. So, like, in terms of doing Rust stuff, I feel like I have. Oh my god. Okay, okay. Anyways, what was I saying? Yeah, in terms of doing Rust stuff, I would be I would be doing stuff with Burn. I would be doing stuff with embedded embedded Rust. Definitely, that's gonna be one as well. I was doing in terms of like programming the ESP32. I was using MicroPython previously, but then now I'm like, MicroPython is great for prototyping. It's amazing for prototyping, and not just prototyping. There's a bunch of stuff that you can do with it. You can set up quite a few projects using MicroPython. But I kind of feel like doing it in Rust and Rust and how do I say this? Embedded no STD Rust, basically. Running on bare metal is gonna give me a lot more performance, and also I would then be able to use other. I don't know how how threading gets implemented in this. Async is definitely a thing. There's a separate crate for that. I don't know how threading gets implemented. I'll have to see how threading gets implemented in this. But yeah, okay. Let's get started with this. Okay. So this is our exercise, and I was doing this over here. What is this? Um. Oh, this was. Hold on. No. What is this? What was I looking up here? Oh, it's the database stuff. Okay. Oh, this is the temp learning thing. Wrong window. You guys can't even see what I was looking at just now. Okay, so here I need to. Yeah, this is the code for Rusty Rain. I should actually close this because the Rust analyzer will be taking up a lot of resources. Okay, so this is where I was with the intermediate. Was I just about to say machine learning? Holy shit! You guys ever have those kinds of slip ups? I was trying to say machine learning, but okay. Anyways, um, this is the code that I've set up so far for the intermediate machine learning course. I also set up a new project for this, And something else that I did is I moved the entire datasets directory. Let me see if I can show it here. I moved, so previously what I'd done is I had like I had the Kaggle learn directory. In the Kaggle learn directory, I created one directory for the pandas course, and that was going to be a Python project. Within that directory, I created a datasets directory, which would have datasets specifically for that pandas course. And there, it just so happened that I downloaded like 8 datasets maybe for that. Hold on, why is this being slow? Is it stuck or okay, yeah, no, we are good. So yeah, so what I'd done is I'd created a directory, a datasets directory within that pandas course Python project directory. And what I was planning on doing is for the next course, which is now intermediate machine learning, I was going to create a separate Python project. But then within that project, within that directory, I would have another datasets folder for that specific course, right? But then I was like, why am I doing this? Because the idea is to have these data sets, right? I'm not planning on deleting these data sets. In fact, I might actually move them to a different machine just so I have a data set storage kind of thing. Because I do have another machine which just so happens to have um, a bunch of free hard drive space on it. So I can like move this entire data set, which by the way, so far is only like uh maybe close to 2 GB, but like it's around 1.5 GB. So I can just move this data set and any other data sets that I download in the future, I could just move them all to that other machine and store them there. And anytime I need anytime I need a new data set from there, I can just like copy it over or something like that. What was I doing? Shit, I forgot. Oh yeah. Um, where here? So so far I've set up this code, which is the code here. I set up all of this code. Let's go over the code real quick. So up here we are loading this entire training data set, and then we are loading the test data set, and then we have our target variable, which is y, which is the sale price, and then we are listing out the features that we want in our what do you call the other variable? I forgot. So you have the target variable, and the other variable is the independent variables basically. But in our features, I guess we'll say x. We'll call it x because the target is called y, and all of the features that are used to predict the target, they come under x. Right. Then we have x test, and then we are doing the test train split. Sorry, zoned out. Okay. Sorry, zoned out again. Okay, so yeah, so far I'm here and I was just loading up. I was trying to load the top few rows from this data set, which is here. So let's run this. Oh wait, I didn't run this. I need to run this first. That is going to throw an error probably. Oh, is it done? Yeah, it should throw an error, right? Which one was I running first? Did I run this first? I think I ran this first. Okay. Anyways, let's run it again. And then run this. And then run this. Okay, there's our data. And that matches up with what is here. Okay, cool. Awesome. Okay, so the next code cell defines 5 different random forest variables. Run this code cell without changes to review random forest. Look here. Okay, I think I might need to um, write out this code. So hold on just a second here. From sklearn. Is IntelliSense not working? Oh, maybe I should restart NeoVim because I've had this session open for like a while. So maybe at some point the LSP stopped working or something. Let me save this and close it and open it up again. Right. So let's open that up and give it a couple of seconds now. All right. Right. Are we good now? No, something is up here. Why are we having issues here? Hold on, give me a second here. I'm not really sure why this is happening. Oh, there it is. Okay, cool. I don't know. I don't know what that was all about. Whatever. Um, what was it? Ensemble, import random forest regressor. All right. Next, we want to define the model. So model underscore one equals random forest regressor. n estimators equals, oh, n estimators is already a thing here. N estimators equals 50, and then random state equals 0, and give me a second here. Okay. All right. Um, so let's do that. Okay. All right. Then model 3, an estimator is 100. Criterion is absolute error. Yeah, okay. I didn't get a chance to explore random forests after that tutorial. I just realized that because I didn't really finish learning, because like I wanted to learn how decision tree regressor worked and how decision trees in general worked. And so I didn't want to like move forward with other stuff until I knew that, if that makes sense. I didn't want to move forward unless I actually understood how this works, how decision tree works, because random forest regressor is a bunch of decision trees inside, right? So I wanted to get a better understanding of how decision tree itself is working. Um, okay, min samples split 20, and then n estimators max depth 7. Okay, great. Now, what are we doing here? Models equals each of these. Model 1, Model 2, Model 3, Model 4, and Model 5. All right, so now let's run this, and let's also run it here. Actually, we shouldn't run it here. It's probably going to take some time. Hold on. Did it not execute? Oh, no, it doesn't. It hasn't executed yet, probably because we haven't fit the model yet. We have to fit each one of them, right? The fitting is where the training will actually happen. Yeah, yeah, okay. So first we have to fit it, then we do the prediction. Okay, then we have yet another thing here from sklearn.metrics, import mean absolute error. Right, so then we want to score, we want to calculate the score for our models. Okay, let's write this out. Score model, it takes model and then x underscore this equals train. Wait, I didn't even know that this was a possibility. I don't think I've ever done this before, where I'm assigning the default value for a function or a function argument as a variable that already exists. I've never done that. It's usually some kind of like constant value that I provide. Yeah, I've never actually done this. To be fair, I mean this the only reason why this is being done here is because there's that assumption that yes, the variable already exists. Y valid. Okay. Okay. Then model.fit x train. y train, then prediction equals model.predict. Oh, it doesn't know what the type is, so it could. What if I specified the type? It's a random forest regressor, right? So if I specify, there you go. Okay, so now it's able to guess. All right, so predict, um, return mean absolute error, which is our predicted value, and no, first comes the true value, right? Okay, so yt, wait, t here is for training, not for true. V is for true. And then we have the actual value. Okay, cool. So then for I in range, 0, len models. I really don't need to be writing this code out here, but like I'm still doing it. I don't know why I'm doing it. Maybe for practice. Okay, models I, and then print model may equals this. What is it? May. All right, let's try running this here. Oh, source env bin activate. Okay, so that's going to take a couple of seconds, hopefully not too long. And this is also taking some time. Oh, hold on. Both of them took around the same time. Cool. Actually, to you guys, it might appear as though on my system it took longer because it might, like the RTMP feed arrives like a couple of seconds later. Either way. Okay, so we have defined multiple random forest regressors, and then we ran all of them. We fitted all of them. We trained all of them and used all of them for prediction. And then we got our mean absolute error score. And it seems like we have something in between here. So model 3 performed much better. Okay, evaluate several models. Fill in the best model. Wait, use the above results to fill in the line below. Which model is the best model? Your answer should be one of these. Yeah, it seems like model 3 was the best, right? Let's try that. Yes, that's correct. Awesome. Let's take a look at the hint and solution as well, and then we can move on to the next one. Which model gets the lowest May score? That's that. Okay. Generate test predictions. Great. You know how to evaluate what makes an accurate model. Now it's time to go through the modeling process and make predictions. In the line below, create a random forest model with the variable name my model. Just create a. Okay. All right. Random forest regressor. Actually, okay, I just remembered the reason why I was doing the stuff on my local machine is specifically because of IntelliSense. And there's also the fact that I'm getting some practice of, writing this kind of code. So that kind of, it does help. Because like if I was writing this, like, hold on, what am I trying to say? If I was writing the code in the notebook alone, then I would kind of be guessing the arguments and the the names of the arguments, as silly as that may sound. I would be I would be having to, visit the website and look at the definition of random forest regressor and then see what's being shown and stuff like that. Or I would have to scroll back up here and look for the thing. But then now I'm just able to, type it out. I'm also able to see it on my other machine, which helps. Are there any? I mean, they just asked for a random forest regressor, right? Nothing more. Okay, okay. I was like, okay, do I need to give any specific arguments or something? Okay, you need only set my model to a random forest model. You are welcome, but not required to choose one of the five models above. Okay, all right. Then run. Hold on, there's a bit more. We'll finish this. Oh, it's the competition. I forgot. Okay, yeah, we are supposed to be submitting this for the competition. We'll submit it because I do want to get more practice of doing competition stuff. I also want to explore that. What was it called? There was something accident and something something predicting road accident risk. I wanted to participate in this. What is it called? Near IPS. The problem is to participate in this, they require you to verify, and I don't just mean like verify your account. They require you to give identity verification. So it's the whole thing with that persona website and stuff. So I was like, okay, you know what? I'll I'll leave because they mentioned this thing here. Hold on, where is it? Wait, it seems like my stream crashed. Are we good? Yeah, I think we are good now, but did my stream die? I don't think so. I hope not. Just a second here. Let me switch to BRB because I need to restart something here that crashed. Actually, I need to restart a couple of things here that crashed. I think my entire like router just noped out. Yeah, I think so because even the SSH connections that I had and oh wait, no. To be fair, the issue it wasn't the router. It was yeah, yeah, never mind. It was this give me a second here. Um which one is it? This one. Was it this one? I think it was this one. No, it wasn't this one. It was it wasn't this one. It was supposed to be other laptop. No, stream desktop stream laptop. Yeah, there. Okay, that's connected. Next we need to connect this thing crashed, right? So let's reopen that. Hopefully OBS picks it up. Yes, okay. OBS picked it up. And finally, we need to do this. Okay, done. Yeah, that's unfortunate. And we are still having like dropping frames. Unfortunately, I Wait, can I like give me a second. I'm doing something here that hopefully will fix the issue. Okay. Are we good now? I think we are good. I hope we are good. I think so. Yeah. Cool. Awesome. That is unfortunate. Um, but it is what it is. Can't really do much about that. Okay. So, where was I? I forgot in between all this, I forgot what I was even saying. Oh, yeah, this competition. I wanted to participate in this, but then they require the whole like identity verification thing. Um, but yeah, they had like interesting things going on here. Something that I liked here was it mentioned each solution file must be entirely self-contained. That is, it should not import code from any other adjacent files in your submission directory. In addition, all imports are restricted to those in the Python standard library. Programs that do not adhere to these restrictions will fail. So I thought that was kind of interesting for them to mention. So it kind of forces you to work with the tools that are available. And yeah, I wanted to try this out. Maybe I still might. I might not be able to. Oh, yeah, this just occurred to me, dude. In order to submit to the competition, I would need this competition requires some. So to submit to this competition, you would need this, right? We could still do the competition, but try out this competition. Okay, we crashed again. We crashed again, and we are back again. Okay, dude. Right. Now, what was I? Yeah. So we could still do it. We could still do it. Now, how do we data code so and so in this competition? Yeah, okay, you know what? I'll leave this for I'll leave this for later. I will join this, but I'm not going to submit to it because, I can't submit unless I do the whole persona thing. But I do want to join it just so we can do like we just so we can see what it's like to solve the puzzles in here. Should be fun. Should be fun. For now, let's get back to this. All right, so what's next? Run the next code cell without changes. The code fits the model to the training and validation data. Okay, that's the model that I just defined. And then generates test predictions that are saved to a CSV file. These test predictions can be submitted directly to the competition. Okay, but like, that's not the best model though. I shouldn't be doing that. Hold on. I should get the if I'm going to be submitting for the competition, I should get the parameters for the best model. Okay, best model equals this. Okay, okay. Or I could just do that. Yeah, I could just do best model. Give it a second here. These test predictions can be submitted directly to the competition using this CSV. See, I wanna get some practice of doing this as well. Like this portion of the work, I don't really have, practice of doing this. So I need to kind of get experience with actually submitting, like exporting the results to a CSV file and then submitting the results to a competition and seeing how they evaluate the score. Why is this taking some time to run? All right. Okay. Model 3, best model. Yeah, why is this taking time to run? Holy shit, this is, oh god, are we about to freeze? Yeah, let me just run the whole thing again. I don't know if my browser is about to. Okay, let the thing start up. Oh, are we good? Right. So let's run this. Is it done? Yeah. Okay. Cool. Then run this. Run this. Run this. Is that done? Oh yeah, it's not going to take time. All right. Model 3. Okay, then best model. Great. Awesome. Then we set this. Okay. And then here we set this up. Okay, that's done. Now, once you have successfully completed step 2, you're ready to submit. What was step 2? Step 2. Oh, okay. You're ready to submit results to the leaderboard. To the leaderboard. Okay. First, you'll need to join the competition if you haven't already. So open a new window by clicking on this link, then click on the Join Competition button. If you see a Submit Predictions button instead of a Join Competition button, you have already joined the competition and you don't need to do so again. All right, so let's open that up. While that's loading, let's continue reading. Next, follow the instructions below. Begin by clicking on the Save Version button in the top right corner of the window. Wait, begin by clicking on the save version. See, I forgot about this as well. This whole thing about like saving and then submitting the output after that. Save version button in the top right corner of the window. This will generate a pop-up window. Ensure that the save and run all option is selected, and then click on the save button. This generates a window in the bottom left corner of the notebook. After it has finished running, click on the number to the right of the save version button. This pulls up a list of versions on the right side of the screen. Click on the ellipsis to the right. This is so hard to read because the text is so small. To be fair, even if it was big, I would have probably still had like a little bit of trouble reading it. But anyways, okay. Click on the ellipsis to the right of the most recent version and select Open in Viewer. This brings you into view mode of the same page. You will need to scroll down to get back to these instructions. Click on the Data tab near the top of the screen. Then, my God. Then click on the file you would like to submit and click on the Submit button to submit your results to the leaderboard. Back up. Hold on, I haven't joined the competition yet. Never mind. I have already joined the competition. So save. Okay. All right. That's done. Now what were we supposed to do next? Okay. And then these dots, then open in viewer. Input. What was the name of my file? Submissions.csv. Yeah, I think that's what I have to do, right? Submit. Okay. Where is the submit button? Hold on. No, I'm confused. What? Okay, save and then come here and then open in viewer. Okay. This is where they were saying we would need to. Okay. I'm supposed to look at output. Okay, I just realized that. Sub Dude, they have these. I feel like these instructions need to be updated because it mentions here click on the data tab near the top of the screen, then click on the file you want so and so so and so. It doesn't say there's no data here. It says input and output. I feel like they need to update these because it becomes confusing otherwise. All right, let's submit this. Okay, submit. All right. Great. We just made another submission. Hell yeah, dude. Awesome. And this time I think we made the submission. So the last time we made the submission with one random forest, if I remember right. This time we made the submission with multiple random forests, and like we picked the best score, or the best scoring one out of them. Okay, cool. So now that we've done this, we can go back here and cool. You have now successfully submitted to the competition. If you want to keep working to improve your performance, select the edit button in the top right of the screen. Then you can change your code and repeat the process. There's a lot of room to improve. You will climb up the leaderboard as you work. You know what? I think I might do that. I think I might do that because I feel like there's a lot for me to learn here, especially in terms of like submitting to competitions. Like there's a lot for me to learn here. I still haven't fully wrapped my head around the workflow. Maybe I can have a conversation with Gemini about how this whole thing works because like it's kind of interesting that I have to do it in this way. So first I have to save the notebook, which I've already saved it. After that, I have to click on the notebook version that I currently saved, that I recently saved. And then here I have to open in viewer. Now, when I open in viewer, this seems to be directly opening up like with this competition thing. Does this mean that if I'm like how would I start this in the first place? I feel like I need to find that out. So I need to go and join a competition and then create a notebook. I think that's the first step. I can't create a notebook and then, you know, join a competition through that. I think the notebook has to be created through the competition page, and then I'm going to be able to do this kind of stuff because that leads directly to the competition page, right? I think so. I'm not sure. This notebook is an exercise for so and so, so and so, so and so. Okay, okay, okay. Yeah, no, I need to. You know what? I think a good practice for me would be participating in that accident risk thing. Though I feel like if I finished learning the extra chapters that are there here in intermediate ML, I would probably be able to do a better job there. So maybe for now I should stick with this housing prices prediction thing, housing prices competition for Kaggle Learn users. Apply what you've learned in the machine learning course on Kaggle Learn alongside others in the course. Right. Okay, cool. So this is done. This is done. This I'm gonna keep this open. I want to see if I can like create a new notebook for this. I want to see what happens like if I just click submit prediction, or like I need to explore. I need to explore this whole thing. Okay, so this is done as well. And yeah, we are done here. So now we can move on to missing values. Let's see what that says. And I can also open up the missing values thing here just so I'm able to read it. Okay, give me a second. Let me hydrate, and then we can continue reading, or we can start reading. Okay, in this tutorial, you will learn three approaches to dealing with missing values. Then you'll compare the effectiveness of these approaches on a real-world data set. Okay, introduction. There are many ways data can end up with missing values. For example, a two-bedroom house won't include a value for the size of a third bedroom. A survey respondent may choose not to share his income. Okay. Most machine learning libraries, including scikit-learn, give an error if you try to build a model using data with missing values. So you'll need to choose one of the strategies below. Okay, three approaches. First one, a simple option, drop columns with missing values. The simplest option is to drop columns with missing values. Unless most values in the dropped column are missing, the model loses access to a lot of it. Wait, what? Unless most values in the dropped column are missing, the model loses a lot of potentially useful information with this approach. As an extreme example, consider a dataset with 10,000 rows where one important column is missing a single entry. Okay, this approach would drop the column entirely. All right, okay. Yeah, so we lose an entire feature that we could have otherwise used in our model. Okay, a better option, imputation. Imputa- Imputation fills the missing values with some number. For instance, it can fill in the mean value along each column. Oh, okay, so we just make up values. Okay. Mean is a good approach. Like you take the average of all of the values in there and you just fill in the missing values with the average. Yeah, that's a good approach. Granted, the data won't be accurate after that, but then data accuracy at that point isn't really the point, right? The concern there is that we're trying to fill in these missing values with something um, that could that could make this entire row useful. That being said, I feel like this would be a better approach if, like they mentioned before, okay, the imputed value won't be exactly right in most cases, but it usually leads to more accurate models than you would get. Oh God, okay. We crashed again. Let's wait for it to reconnect. Okay, I think we are back. Right. The imputed value won't be exactly right in most cases, but it usually leads to more accurate models than you would get from dropping the column entirely. Okay. Then an extension to imputation. Okay. Imputation is the standard approach, and it usually works. However, imputed values may be systematically above or below their actual values, which weren't collected in the dataset. Or rows with missing values may be unique in some other way. In that case, your model would make better predictions by considering which values were originally missing. Let me read that again. Your model would make better predictions by considering which values were originally missing. Okay, bed was missing. Oh, so you create a new feature in which you mention which values from another feature were missing. So you're essentially creating a new feature there, and then you can use that as another feature for your prediction. Holy shit, I never thought about that. That's crazy, dude. Yo, we just learned something. Okay, in this approach, we impute the missing values as before, and additionally, for each column with missing entries in the original dataset, we add a new column that shows the location of the imputed entries. In some cases, this will meaningfully improve results. In other cases, it doesn't help at all. Okay, example. In this example, we will work with the Melbourne house data set. I keep saying Melbourne. I think it's because I remember Jason Bourne. Though I think it's supposed to be Melbourne. Whatever, I don't give a shit. Um, let's say Melbourne data set. Our model will use information such as the number of rooms and land size to predict home price. We won't focus on the data loading step. Instead you can imagine that you are at a point where you already have the training and validation data in xtrain and okay in all of those variables. So let's take a look at the code here. Okay, what are we looking at? Right, so we load the data set. We load our target variable as well. Then to keep things simple, we'll use only numerical predictors. Data.drop price access. I need to look into what this does. And then also select D types. Okay, so this can be used to I wonder if this can be used to select all the columns that are of a specific data type. Yeah, I wonder if that's what's going on here. Where can I test this out? Hold on. Let's try that with x full. Okay, x full dot um, select d types. What does this do? Returns a subset of the data frame's columns based on the column types. Parameters include exclude, which is a scalar or list like a selection of d types or strings to be included slash excluded. Okay. All right. Let's what hold on. What kind of data do we have here? Okay, these are all numbers. Okay, let's take a look at X full. Um I should get rid of that for loop, dude. Hold on. Right. So here, what I could do is, I forgot what the D-type names were. Float 64, I think. Print. Um, Include. Only include. Wait a minute. Hold on. What's going on here? Xfull is supposed to have a select dtypes function, and it does. Okay. All right. So include equals, um, I don't know, let's say float 64. I forgot what the dtypes are actually called here. So I don't know if this is really gonna work out, but let's print out head. Okay. Yep, that works. Select dtypes. That's what, okay, that's what that does. Data.drop. I'm assuming that just drops the entire column from the data frame. And then we are, yeah, yeah, that drops the data from the entire data frame. So let's test that out. Drop specified labels from rows or columns. Remove rows or columns by specifying label names and corresponding axis, or by directly specifying index or column names. When using a multi-index, labels on different, okay, that's multi-index. Fine. Great. Cool. Okay, then we divide the thing up into our split. All right, then define function to measure quality of each approach. We define a function score dataset to compare different approaches to dealing with missing values. This function reports the mean absolute error from a random forest. Oh, accidentally dropped one of my mice. Where? Here. Okay. Okay. Function for comparing different approaches. Oh, so this can be called multiple times with different, I'm guessing the variable here would be the different splits, I think. Wait, no. Each time the random forest has this exact same thing. But yeah, I mean, if we are defining a function for comparing different approaches, where's the different approach though? Like, what is? Oh yeah, okay. The different approach is like within the data, because we are kind of modifying the data set, or we are choosing what data we are going to be passing in. So here the focus is on the data itself, not on the variables of the not on the parameters of the ML model. So this way we are able to pass in like different forms of the data set and we are able to see how it performs. That's crazy, dude. I had no idea we would be learning this. Like when I said that I knew how to handle missing values, I knew only up to handling the missing values, which is, finding if values are missing and filling them in if necessary. But I didn't know any of this other stuff, these techniques. Okay, so approach one is to drop the column. Approach two is imputation. Oh, good. Okay, scikit-learn has. Okay, as we can see, approach three performed slightly worse than approach two. Okay, all right. So why did imputation perform better than dropping the columns? The training data has around 11K rows and 12 columns, where three columns contain missing data. For each column, less than half of the entries are missing. Thus, dropping the column removes a lot of useful information.